Okay, so I am lecturing from an already filled in lecture notes because my board at work at home is not working. So today we're looking at section 9.1, which is quadratic graphs and their properties. Now what you're going to do today is you're going to graph the functions in the form of the y is equal to ax squared and y is equal to ax squared plus c. Now a quadratic function is a type of nonlinear function that models certain situations where the where the rate of change is not constant. So since the rate of change is not constant, that means that it's not going to be linear, okay? The graph of a quadratic function is a symmetric curve with a highest or lowest point corresponding to a maximum or a minimum value, okay? Now, let's take a look at the standard form of a quadratic function. The standard form of a quadratic function is a function in the form y is equal to ax squared plus bx plus c, where a is not equal to 0. That is called the standard form of the quadratic function. Okay? When we have, these are examples here of equations that are in standard form. We have y is equal to 3x squared, y is equal to x squared plus 9, and we have y is equal to x squared minus x minus 2. And we will find in this lecture why they are different, okay, and why they are similar also. All right, so here we have a picture of the parabola. Okay, this is the graph of the quadratic function, and the graph is called a parabola. The simplest quadratic function is called the parent function, the quadratic parent function. And you guys know what a parent function is, just like the parent function of the absolute value. It's where all of the quadratic functions, they start from the parent function. So the parent function is y is equal to, f of x is equal to x squared, and f of x, of course, you know, is function notation, and all it means is y is equal to x squared. So that's the same thing. And again, this is what the graph of the quadratic function looks like. It's called a parabola. Alright, so you can fold a parabola so that two sides match exactly. This property is called symmetry. Okay? The fold, or the line that divides the parabola into two matching halves, is called the axis of symmetry. And you guys have all done this. I'm pretty sure you've done this when you're making a Valentine's Day for your mom, when you're a little kid in elementary school, and you fold the paper in half, and then you cut just half of the heart. Okay? And then when you open it up, you have a full heart, but you can see where you folded it. That fold is the axis of symmetry. And here's some other pictures here. We have a star where the axis of symmetry is right there. And if you look here, the axis of symmetry, you also have one here, and here, and here, and here. Okay, so there's several axes of symmetries there. In this triangle, you have the axis of symmetry going right down the middle there, but you'll notice that if we fold it the other way, you do not have symmetry if you go from this point to the other side, to the opposite side. And then if you look at your parabola, when you look at the parabola, the axis of symmetry goes right down the middle. Okay? Now, the highest or lowest point of a parabola is called the vertex. Okay? And the vertex is always on the axis of symmetry. Okay? Now, when we have an equation here, we have y is equal to ax squared plus bx plus c. And if you look at the a, that's a positive a. So a is greater than 0. If a is greater than 0, that means that the parabola opens upward. Okay? So the parabola looks like this. Okay? So when the parabola opens upwards, the vertex is in the lowest point of the picture, so it's a minimum point. Okay? When we have an A that is less than 0, when we have an A that is less than 0, that means that A is negative, then the parabola opens downward. Okay? And the vertex, you'll see it right there, right at the very top of this parabola. Okay? And since it's at the top at the top or the highest point, that's called a maximum. So, when A is greater than 0, meaning that A is positive, the parabola opens upward. When A is less than 0, well, that means that A is negative, the parabola opens downward. Okay? When the parabola opens upward, we have a minimum. When the parabola opens downward, we have a maximum. All right. So problem 1 is identifying a vertex. And we want to know what are the coordinates of the vertex of each graph. Is it a minimum or is it a maximum? And we want to determine what are the coordinates of the graph. So when we look at the coordinates, it's always going to be an x comma y. Okay, we want to know the coordinates of the vertex of the graph. So when you look at this picture in graph A, you can see that the vertex is right there. Right there. It's at the top of the parabola. So since we know it's at the top of the parabola, we can already answer, is it a maximum or is it a minimum? Because it's at the top, it's at the highest point, it is a maximum. Very good. And what are the coordinates of this point? The coordinates would be 0, 1, 2, 3. Very good. Very good. So the vertex is at 0, 3, and it's a maximum because it's at the top of the vertex. Okay. Now, if you think about what the equation looks like, because it's opening downward, we know that A, or the coefficient in front of the x squared term, is going to be less than 0 or it's going to be negative. Okay? So, graph B, when we look at graph B, we've got a parabola that opens upward. So what do you think the equation or the A is going to be in the equation? Because it opens upward,